Hi there. Today we're going to be talking about multiplying polynomials. In these problems here, they're going to be a little bit smaller, and then we're going to move forward to looking at some bigger ones in a second video that you'll see later. So let's go ahead and get started. So before we start multiplying polynomials, we kind of talk about some properties of exponents. When we talked about adding and subtracting polynomials, all we did was add or subtract the coefficients only. We didn't do anything with the exponents. We told her to leave the variables as they are and just combine our like terms. Well, when we're going to be doing multiplication, it's going to look a little bit different. So let's take a look at an example here. So if I have x to the fifth times x to the seventh, so these have the exact same bases, means they both are x's, and the exponents represent how many times you multiply something. So for example, x to the fifth is x times x times x times x times x. And I can rewrite x to the seventh as x times x times x times x times x. So that's 7 times, okay? Well, this is just one big multiplication problem, and they're all x's, and ultimately I have myself 12 x's. So I can really rewrite this out as x to the 12th power. And so what we can kind of come up with is a shortcut to that. Since they have the exact same bases, we have our product of power rule here. They have the exact same bases. Whatever the exponents are, we can add them together. So this is a really important rule for you to write down. The product of powers, a to the b times a to the c equals a to the b plus c. And you can see it taking place in the example right above that. Okay? All right, so let's look at an example of that. So I have here 6y to the third times 2y to the fourth. All right, now I got coefficients and then I got variables here. Since everything is being multiplied, there's no plus or minus in between or anything like that. What I can essentially do is take the 6 and the 2 and multiply them together, and I can separately do y to the third and y to the fourth with each other, okay? Since it's multiplication, I'm allowed to move anything wherever I want. Well, I can do 6 times 2. 6 times 2 is 12, and y to the third times y to the fourth, remember in the rule, we're going to add them together. So 3 plus 4 is 7. And that's all that we have to do with that. And this is probably the most important rule for you to kind of keep in mind. Well, now let's take a look at letter B. Now, letter B is a little bit different because we have this quantity inside the parentheses, and then we have the exponent of 2. Well, again, keep in mind, when I have something in a parentheses and I got that 2 on the outside, that means I'm multiplying it by itself. So what you're going to do is rewrite it however many times this exponent says. So since it says twice, I'm going to write out 5x squared y z to the fourth, and I'm going to times it by 5x squared y z to the fourth. Okay, so I'm just writing in however many times that exponent says. Well, just like the first example there, we can then go ahead and multiply things and add exponents. So coefficients, the big numbers, they're going to get multiplied because, again, this is a multiplication problem. So 5 times 5 is 25. Now I'm going to look at the variables one at a time. I've got an x squared and an x squared, so altogether I have 4 of them. For my y's, even though there's no number there, it's like there's a number 1. So I have 2 y's altogether, so that's going to become y squared. And then z to the fourth times z to the fourth altogether is z to the 8th. So be really careful and make sure that you are adding the exponents and not multiplying them. Okay? Let's apply this to something a little bit bigger. So I have here the 5x squared. Now I'm multiplying it by 2 things. I got the 6x plus the 6. So there are a couple methods that you can do this by. We can do it by distributing through with the 5x squared times 6x plus 6, or we can do something called the box method. So let's show it with the distributive method, and I'll show the other one with the box method. So when I distribute, I'm essentially going to multiply everything by that 5x squared. So I'm going to get 6x times the 5x squared plus the 6 times 5x squared. Okay, and then from there we're going to multiply with what we have. Coefficients get multiplied, so 6 times 5 is 30. And then I have an exponent of 1 plus the exponent of 2. Altogether, I have 3 x's, so that's x to the third. Then 6 times 5 for the second one is 30. And the x squared doesn't have any other x's to combine with, so it's just x to the second power. Okay, so when there's a monomial in the front, go ahead and just distribute it through. That's probably the easiest method for you. We're not combining anything because one has an x to the third and the other one is x squared. Same deal with this one. I'm going to go ahead and distribute this through. So that means I've got 2p squared times 6p. Then I have a negative 2p times 6p. And then I have a positive 3 times 6p. And one at a time we're going to multiply. 2 times 6 is 12. And I have 3 p's altogether. Negative 2 times 6 is a negative 12. And I have 2 p's altogether. Positive 3 times 6 is 18, and I only have 1p. I got a cubed, a squared, and a 1. I don't have anything that can combine, so we're finished with that problem. Once we get things a little bit larger like this, that's when we're going to start using a different method called the box method. And it's very simple. All right, what we're going to do is we're going to create a box. That's the size that we have here. Now we have two binomials, so that means we're going to do a 2 by 2. You're going to choose one of them to go at the top, so I have 4m, and then I have the positive 8, and then the other one's going to go along the side. So 2m and a negative 5. And what you're going to do is fill in the boxes and with whatever the product is. So for example, this top left one, I'm going to do 2 times 4 to get 8, and then m times m is m squared. Then I'm going to move to the next box, and I'm going to do the product of 8 and 2m. Well, 8 times 2 is 16, and I only have 1m. 4 times negative 5 is negative 20, and I only have the 1m. And then negative 5 times 8 is a negative 40. Be careful with those signs. What you're going to see now with the box method is that on the diagonals, we're going to have ourselves like terms. You see how they both have a single m? So we're going to combine those together. Our final answer, we usually go from biggest exponent to smallest. 8m squared had nothing to combine with. So now we're going to combine 16 and negative 20. This is where we're not doing anything now with the variables. We're focusing only on the coefficients when we did adding and subtracting. 16 minus 20 is a negative 4m, and then a minus 40 because it has nothing to combine with. Okay? All right, so some key things to remember. We're going to get more practice tomorrow. If you have to combine like terms, do so like we did in that last example. Multiply everything that has to be multiplied. Okay, remember, keep in mind which one's adding and subtracting and which one is going to be multiplied. Use the distributive property for problems like when there's a monomial outside. We can use box method otherwise. And really, really be careful with your signs. Okay, make sure you complete the survey. See you tomorrow.